Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In the previous video, we saw the types of bodies and various types of loads and various types of deformation depending upon those load. Now in this lecture, we will see what do we mean by stress and strain. Okay, now for that purpose we will have to first understand the resistance which is developed in the material of the body to the deformation. We know that whenever we consider a body of elastic material, when external loads are applied, it will deform. Now this deformation of the body is resisted by the material of the body. Okay, now for that purpose let us consider a bar of elastic material. Let us say that it is subjected to axial tensile load, say P. In the last video we saw what is tension. Because they are of pulling nature, it is tension. Axial tension. Why it is axial, that also you know. Because the load is acting along the axis of the body. Okay? Now, let us consider a section. I will consider a section XX. Okay? Now, let us consider this left hand side of the body . Okay, and this is the right side of the body, that is right side of the section, left side of the section. Now when this load P acts on a body, as this is tensile load, the tendency of the body is to extend, that is extension, that is deformation, and this deformation is resisted by the material of the body. Each and every part of the material of the body will resist, it will not allow it to extend, it will not allow it to deform. So this resistance will be normal to the cross section. So this is the resistance offered to the deformation. Each and every part in the material of the body will resist this deformation of the body. Now let us consider the right side. So this will be resisted at this cross section. So this is again a resistance. We have assumed that the section is taken. If you again superimpose, R and R will cancel and that will be the complete body. Now, this resistance offered by the material of the body to the deformation due to load per unit cross-sectional area of the body is known as the stress. Stress is denoted as, it is simple stress or direct stress. It is denoted by letter sigma. What I have told you, what do you mean by stress? Stress is the resistance offered to the deformation of the body. Per cross-sectional area of the body. Or you can say area resisting deformation also. Okay. Now, if you see, for equilibrium purpose, I can very easily see for this one, for equilibrium, this R will be equal to P. Here also I can say for equilibrium, R is equal to P. So whatever resistance is offered, if this is a bar, so 1, 2, 3, 4, 5, 6, all these resistances are nothing but parallel forces, and their resultant will be the total resistance. It is equal to P. Therefore, I can say sigma is equal to, come on, total resistance is nothing but the external force applied upon, if I say the cross-sectional area of the bar is say A, then this will be the expression for finding out the stress. Now, as this stress is acting normal to the cross section, this is also known as normal stress or direct stress or simple stress. Now, mind well, if you are asked to define the stress, you cannot say it is P by A, but you will have to say that whenever the external load is applied on the body of elastic material, it will deform. Such a deformation is resisted by the material of the body, and such a resistance to the deformation per unit cross-sectional area is known as stress. Therefore, the expression to calculate stress is sigma is equal to P by A. This is the definition of stress. Okay? Now, let us see what are the units of stress. So, this is direct stress sigma, that is P by A is the formula. Okay? Now, here you can very easily see that this axial load is of tensile nature, pulling nature. So, the nature of stress will be same as nature of load. So, this stress will be tensile. Okay? Because if it is push, then the stress will be of pushing nature, that is compressive nature. Now, let us see what are the units of stress. Now, as it is load upon area, the unit of stress is Newton per meter square or Newton per mm square, Newton per centimeter square, like that. Now, 1 Newton per meter square is known as 1 Pascal, which is denoted by PE. The SI unit of stress is Newton per millimeter square. You can also express the stress in Newton per centimeter square, like that. Okay? So, this Newton per meter square is Pascal. Now let us see what is the relation between Newton per mm square and this one. Okay? Now, as far as the units are concerned, whenever it is multiplied by 10 raised to 3, it is kilo. K is small. Whenever it is multiplied by 10 raised to 6, it is mega. Whenever it is multiplied by 10 raised to 9, it is giga. What do you mean by this one? 10 raised to 3 means kilo. So if I say ten raised to 6 Pascal, it will be 10 raised to 6 means megapascal. 1 megapascal. M, P is capital, A is small. Now let us see what is the relation between megapascal and Newton per mm square. Now here it is 10 raised to 6. Now as far as units are concerned, you can do the multiplication and division like the numbers. See, look here, I want to convert megapascal. So 10 raised to 6. So 10 raised to 6. Pascal means Newton per meter square. Okay? Now, 10 raised to 6 Newton I will keep like that. Meter square. 1 meter is equal to how many mm? 10 raised to 3 mm. So 1 meter square is square of 10 raised to 3. It will be mm square. Therefore, this will be 10 raised to 6 Newton divided by square of 10 raised to 3 is 10 raised to 6 mm square. This ten raised to 6 will automatically get cancelled, and you can say that 1 megapascal is equal to, yes, 1 Newton per mm square. Very important. Similarly, I will go one step ahead. So if I say 1 gigapascal, giga means 10 raised to 9. So I will write 10 raised to 3 megapascal. Do you understand this? One step ahead. Now 10 raised to 3 megapascal means 10 raised to 3 Newton per mm square. And 10 raised to 3 Newton means 1 kilonewton per mm square. So this is very important to keep in mind that these two are very important expressions as far as unit of stress is concerned. 1 megapascal, that is 1 MPa, is equal to 1 Newton per mm square, and 1 GPa is equal to 1 kilonewton per mm square. So these are the units of stress. Okay, so how can we define a stress? Stress is the resistance to the deformation per unit cross-sectional area, and it is P by A. For equilibrium, total resistance is equal to P. Okay? So these are the units of stress. Now let us go to the next, that is strain. Units of stresses are very, very important. Please keep in mind. Now let us see what do we mean by strain. Strain. Let us say that strain is denoted by small e or epsilon also. We will call it as small e. Again, consider the same, that is this particular bar of elastic material subjected to axial tensile force. Now, we know that due to this axial tensile force, this bar will elongate, this will extend like this. Its cross-sectional area will reduce, but the length will increase. Let us say that its original length is L, and due to extension its length will decrease. Let us say that it is L plus delta L. This is the length of the bar after application of the load. Okay? So consider the bar of elastic material subjected to axial tensile load P. Due to this axial tension, there will be extension of the bar, and the length L will get extended to L plus delta L. Therefore, what is deformation here? The deformation delta L, deformation will be delta L. Now this extension or deformation is resisted by the material of the body. Therefore, whenever there is a deformation, only then the stress can be induced in the bar. Okay? Now this deformation of the bar per unit original length is known as strain. Moreover, as this strain is in the direction of length, it is known as linear strain. So strain, how can you define a strain? Strain small e is equal to deformation upon original length. Therefore, E will be, what is deformation? Deformation is nothing but final length, that is L plus delta L, minus original length, that is L, upon original length is L, and L plus delta L minus L, that is, it will be delta L upon L is known as linear strain. Okay, strain in the direction of length. So this is the expression for strain. Now, what is the unit of length? Meter, centimeter, mm. What is the unit of change in length? Meter, centimeter, mm. Okay, so this is meter upon meter, mm upon mm. As it is the ratio of same type of quantities, it has no unit. So strain has no unit. So in this video lecture, we saw the definition of stress, simple stress, direct stress, that is the resistance to the deformation per unit cross-sectional area is known as stress. And what is strain? The deformation per original length is known as strain. Okay, resistance to the deformation per original cross-sectional area is stress, and the ratio of deformation upon original length, that is change in length upon original length, is strain. The unit of stress are Pascal, megapascal, gigapascal, kilopascal, that is Newton per meter square, Newton per mm square. Very important thing, 1 megapascal is 1 Newton per mm square and 1 gigapascal is 1 kilonewton per mm square. As far as strain is concerned, as it is the ratio of same type of quantities, it has no unit. Okay. So with this, we stop here. In the next lecture, we will continue about Hooke's law and other things. Thank you.